Welcome back to everyone who's online. So my name is Lise Jaillon. It's very good to see you again. And our third speaker is Dr. Tony Russell-Rose from Goldsmiths, University of London. So thank you so much, Tony, and welcome.
Okay, great. Thanks for that introduction, Lisa, and very nice to be here. So I hope everybody can hear me and see me okay. Great. So yeah, as Lisa said, the title of my talk is Searching Fast and Slow. And what I want to do is bring together, I guess, a collection of thoughts and ideas around the process of search based on sort of some practitioner experience and a fair bit of research over the past few years. So to kick us off, just let me figure out, is this the right button to advance the slide?
Yep, just click on this.
Okay, it's just a little bit sticky. All right, so my background, I've worked at the intersection of user experience and information retrieval and natural language processing over many years. I'm actually an academic now, I can't say that word. But for many years, I've worked in industry in various, usually in R&D capacities, but also in professional services and product development, lots of different environments. So a little bit of a hybrid background, but pretty much everything that I've done has been at the intersection of UX and information retrieval and NLP. And what I'm going to be talking about today is really kind of sits at the intersection of those three disciplines. So that's my background. So what I'm going to be talking about is some work really around this idea of professional search. So now most of us are familiar with search. You know, we're all familiar with Google and Bing and how search is woven into the fabric of our everyday lives. And we, in many ways, take it for granted. But the point is that some people need search more than others. And the disciplines that I'm thinking about here are people who are doing like pattern searching, where there's a due diligence involved, or healthcare, where health and social policy is typically based on a very rigorous process of evidence synthesis that's based on systematic searching, but also other disciplines as well, recruitment. As I'll show you in just a moment, the recruitment industry is very much based around structured systematic search. And in media monitoring and competitive intelligence, again, very different disciplines, but what they have at their heart is the need to do search in a very systematic and rigorous way. And for these people, simple keyword search is not going to be good enough. So they need something that is a bit more comprehensive, a bit more repeatable, and a bit more transparent. And I suppose one of the things that I've been contemplating since this morning's talks is the extent to which this applies to archival search. And I think there's somewhere along this discipline, obviously, there's a number of folks who will do archival search, will do it in a fairly discretionary, not quite throwaway, but certainly in a manner which is, you know, that they don't necessarily need to persist that search. But the kind of searches that I'm talking about are those where the search has some value and it's the result of some effort, and that people want to maximize their investment in that effort. So to give you an example of a practical example of how these searches are created for all these different professions, most of you will be familiar with this kind of interface, which is what's typically called an advanced search interface. And we're all familiar with them. You can see that it's generally composed of a set of form fields, and the form fields encourages you to articulate a series of Boolean expressions, and then those Boolean expressions are put together to create a complex, what we call pre-coordinated search. And maybe for some of us in the room, we're familiar with the interface, and perhaps for others in the room, we're familiar with the output. And the output of a complex search strategy would typically look like this. And some people might be thinking, you know, they're not familiar with this, and that's totally understandable. But if you actually have a look at it, you can see that it's kind of like almost like a mini programming language. It's composed of the Boolean expressions plus keyword terms plus control vocabulary terms, plus a lot of expressions that put all those terms together. And this is a search strategy from a published piece of work. You can see the citation at the bottom there. And typically, certainly in healthcare at least, when people do systematic searches that are used for to answer fundamental questions in evidence-based medicine, it's vitally important that they document those healthcare strategies and normally publish them along with the systematic review itself. But I mentioned it's not just healthcare, even in recruitment. If you do a Google search for Boolean strings, you'll probably find that 9 out of 10 of the first results are all created by recruiters. So they have at the heart of their professional practice the ability to formulate complex Boolean strings and Boolean search strategies, which typically might look something like this. And that would give rise to a set of results of social profiles for candidates who would fit their brief. And that's very often how the sourcing or recruitment process works. But I mentioned there's several other disciplines that have structured search at their heart. This is a patent search. And again, you can see the kind of the structure that's going on here. You've got line numbering, you've got the keyword terms, and you've got some controlled vocabulary terms, and you've got the Boolean expressions that connect that whole thing together. Oh, incidentally, I'm just going to leave you with a little question, actually. I'm just going to go back to this previous one. If you look at this healthcare strategy, I'll just pose a little challenge. Can you visualize in your head what that search strategy is actually trying to do? And by visualize it, I just mean in terms of conceptual blocks. It is possible if you look at it for long enough, and certainly if you have a trained eye, you can probably do it. But I'll just leave that as a little challenge, and I'll return to that a little bit later in the talk. Okay. So, as I said, there's various other disciplines where systematic search is important. We've gone through healthcare, recruitment, patent search, and also media monitoring. Here's another example. This is from competitive intelligence, trying to find media associated with a certain individual and a certain set of other keywords. And these kind of searches are very, very popular, very common across various professions. Here's another one from competitive intelligence. They can get very, very large, very complex. In fact, this is just a fragment of a very large search strategy that was too big actually to include in PowerPoint. So I'll just focus on the background to this as well. Is that it's a growing problem. You can see that in healthcare, for example, the number of systematic reviews that have exercised this kind of advanced search functionality have grown over the years, and of course the content that is being searched has grown equally at a similar rate. So it is a growing problem, and understandably, there's been certain tools and techniques and processes and mitigations that have been put in place to deal with this. And one of these in particular is the flowchart, the Prisma flowchart, which is a process for effectively doing the searching part of the systematic review. So you can see here that this process really is a framework for doing that search in a repeatable evidence-based manner. So you have the phases of identification, and then screening and eligibility and inclusion, which leads from thousands and thousands of citations at the top down to a handful at the bottom that is actually included in that systematic review. So what I'm trying to articulate here is obviously there's a growing volume of data out there, which is probably a good thing. There's a growing volume of tools and approaches and flowcharts and frameworks that can help with this complex search process. So what could possibly go wrong? Well, it turns out that actually at the heart of this is our friend, the Boolean string. And most of us have relied on Boolean strings for several decades, really since the first days of information retrieval systems back in the 50s and 60s. But it turns out that the Boolean string itself is somewhat ineffective for communicating structure, which is ironic, seeing as it's the primary technique for doing structured search. As you saw from those examples that I showed a moment ago, without the visual cues, it's very hard to actually determine where the search starts and ends, and how it's actually composed and how it's constructed. And further to that, they don't scale well. You saw with the examples, when they get longer and longer, there is no, well, in a programming language, of course, you would have abstraction and encapsulation and object orientation and inheritance that would allow you to see both the overview and the detail on demand. But of course, there's no facility for doing that within Boolean strings. As you add terms, it just gets longer, so you have to deal with that complexity. So those are the two analytical arguments, and then there's an empirical argument as well, which is simply that they're very error prone. There's been various audits done of the search strategies that have been associated with systematic reviews and published as the evidence base for those systematic reviews, and there's been a remarkable number of errors found when the audits have taken place. As many as 90% in some cases of search strategies have been shown to have errors of some form or another. So really this kind of begs the question of why is there such a problem? Why is it we're still working with this somewhat flawed process and somewhat flawed tooling and somewhat flawed approach? And this is where a little lateral thinking, I think, has inspired the work that we've done over the past few years, where we've looked at how software engineering has evolved over the past, 2, 3, 4 decades. And we've kind of reflected on this, and we've seen that search strategies in some ways share some of the characteristics of software in the sense that they're complex logical constructs. The ones that we deal with that I've shown you here are read typically many more times than they're written. They do possess or they would need to possess the qualities of abstraction and modularity and encapsulation in order to be scalable. And they need to be maintained and shared and optimized amongst all these professions, possibly slightly less so with patent search because it's so competitive and the IP is, of course, highly protected. But in all the other disciplines, sharing is a common practice, and optimization and maintenance is a common practice. So this kind of alludes really to search strategies as software or search strategies as code. And the idea then, there's two ideas, is what can we do? What can we borrow from the software engineering discipline that might help us maintain and debug and create search strategies? And where are we on that spectrum? If we look back at the development of, the software engineering profession, if we were to pick a point, where would we be on that spectrum when it comes to designing search strategies? And there's this little quote here from the history of visual development environments about how software development used to be done. And in some ways, search strategies very much borrow from this sort of rather idiosyncratic, non-repeatable approach, but it's still taken as common practice. So that really leads on to the sort of analogy that's underpinning this talk, which is a lot of what's done, the kind of paradigm behind search strategy development is resonant of what Daniel Kahneman in his book, Thinking Fast and Slow, called System 2. For those who are unfamiliar with this book, it puts forward the idea that intelligent behavior is underpinned, or human behavior at least, is underpinned by two approaches. The System 1, which is what you might call the intuitive approach, fast, automatic, frequent, stereotypical and unconscious. So the sort of thing that helps you navigate as you're walking along, determines that one object is bigger or further away than another. We don't consciously make those decisions or cognitions, but we benefit from them nonetheless through this fast System 1. And then there's the more sort of symbolic processing that we typically associate with what we call intelligent behavior, which is generally slow and effortful and infrequent and logical and calculating. So determining the validity of complex expression or writing a search strategy is very much a System 2 behavior, a little bit like writing code. So the question then was really, well, can we, if it's all System 2 at the moment, why can't we try to do something that helps us benefit from the System 1 approaches? So that really takes us on to this sort of dichotomy, where on one side we've got the slow thinking, which is how things are done at the moment. If you look at those search strategies that I showed you, they tend to be procedural. And the question is, can we turn them into something declarative over on the right-hand side? And they're certainly static. There's not a lot you can do with them other than copy and paste them. Can we make them interactive? And then monolithic. They're just big blobs of text. Can't we make them executable, and can't we interrogate them in a way that gives us more insight into their semantics and behavior? And they're effectively their strings with all the limitations that implies. Can we turn them into objects and have them exhibit some more intelligent or useful behavior within a larger ecosystem associated with creating and formulating search strategies? So that gives us this kind of challenge that what if we could forget about the search box and start thinking about search strategies as a visual challenge, and use metaphors that the user already understands, visual metaphors where appropriate. And then think carefully about the allocation of function between the various tasks that are involved. We've seen from this morning how keyword selection is a very important part of that, choosing the right vocabulary terms, choosing the right controlled vocabulary terms or thesaurus terms is clearly quite a challenge. And then there's the manipulation part, stringing them together into the appropriate expression that is syntactically correct and also semantically correct. But can't we go further that? Can't we do all the things that we take for granted within a software IDE, like providing a scratch pad for ideas and debugging aids, rather than just a text editor or Microsoft Word? And can't we also provide some instant feedback that shows where searches are effective or not effective, and provide some sort of guidance to the searcher that helps them create meaningful search strategies and productive searches? And can't we also manage complexity in a smarter way, rather than just saying, oh, the string's just going to get longer, that's it? Can't we support abstraction and then allow people to see the detail overview and the detail at the same time without needing to just cut the thing up or paste it somewhere else? And back to the thing about the challenge of keyword selection, can't we, in the moment, provide query suggestions that are contextually relevant to what the searcher is actually trying to achieve? So I should point out, though, that we're not the first to take up this challenge. There's actually a huge history. Before I talk a little bit more about what we've actually done, I should point out that there's a huge literature history on this, and in some ways we've stood on the shoulders of giants. Going all the way back to 1989, a seminal piece of work here from Anik et al. Showed the idea of creating a search as a visual composition on a two-dimensional canvas with these little tiles that could be dragged and dropped and manipulated to create complex Boolean expressions, or certainly complex expressions that would represent a composite information need. And there's some interesting ideas here with the hit counts on these little tiles and the inverse video to suggest negation. And there's also other little cues built into this, the left to right reading and the vertical stacking to represent disjunction. So there's lots of interesting ideas in that. And more recently, there's been the work from Fishkin and Stone, which have looked at Boolean searches as a set of layered filters, where you can place them on top of each other to progressively refine your search and combine them in interesting and productive ways to express a composite information need. And in the practitioner space, there's been various others who've looked at this challenge. You can see here, I think this is called Boolio, which is developed by a recruiter. It's the same idea of a two-dimensional grid, but rather than manipulating tiles, we're simply adding the terms in, and there's a conjunction across the columns and a disjunction within the columns. And this is quite a reasonably effective way of articulating complex searches for in the recruitment profession, although there is a built-in limitation to this, but I'll leave that as an exercise for the reader, whoever can figure out what that is. And more recent, sorry, there's one other example. This is from the librarian community. This is from David Newman and his group down at, I think it's Exeter. And he's created a similar sort of thing with spreadsheets based in Excel. Again, similar idea, two-dimensional grid, and the conjunction applies across the columns, and then the disjunction within the columns to create a complex composite search. And back to the academic community, there's the work that's done with, I think it's Bond University in Australia, Harry Sells and Justin Clark, working on a platform called Search Refiner, which you can see here the traditional text-based search strategy over there on the left, but you've got a tree-based visualization there on the right, and both of these can be independently manipulated and also provide other information on the quality of the search. So we've kind of, in the work that I've been doing with my colleagues, we've borrowed ideas from all these people and pulled them together in a platform that we call 2D search, 2D meaning the two dimensions. And in some ways, the static visual here doesn't quite do it justice, because it's like trying to, well, the analogy that we give is it's like building Lego. You can build arbitrarily complex constructions from some very simple elements, because it's all about how they combine. And obviously, we can't convey the how flexible that is with a static visual, but you can get the idea that you can see this is one type of visualization where the blocks have been combined together in what we call the this is the nested view, and that confers some immediate benefits. But the idea of getting brackets in the wrong place is simply designed out, because you can only create syntactically correct expressions on the canvas. Arguably, it makes the semantics more transparent. Remember that search strategy that I showed you, I think on slide number 4, and left you with the challenge of try and visualize that. In this case, of course, you can see the visualization is the whole paradigm right from the outset. And as I said, it also supports arbitrary levels of abstraction. One of the problems with the Boolean string is they just grow monotonically in length as you add complexity to them. Whereas here you can collapse and expand things and walk up and down the tree and see the overview or the detail as you prefer. So as I said, that really gives what we like as a sort of a Lego analogy, where it's a playful type of interaction. Nothing ever gets broken. You can undo or redo things. You can save things. You can import things. All the sort of things that you might do in the physical world with Lego, building complex but useful things out of elementary building blocks. And there's lots of other interrogation, but it's a little bit more interactive, I guess, than Lego, in the sense that you can execute all these objects on their own, or enable or disable them, like commenting out lines of code. And we borrowed the ANIC idea of putting the hit counts in the top right-hand corner to give the user a sense of where the central gravity is with their search. Or if one particular part of it is failing, then they can see that with the hit counts. So that's kind of the, I guess, what you might call the syntactic side of it. Then there's the semantic side of it, which is what happens. How do we actually execute these searches? We've seen how we can create them, but how do you execute them? And that's where we've built what you might call an abstraction layer of connecting to various databases underneath. I should add only publicly available databases, but there's no reason technically why we couldn't configure against private databases, and we have done that with various instances of Elasticsearch and other on-premise instances. But we're connected to 12 publicly available databases at the moment, which you can they're not visible in this visual, but you can see there's a drop-down menu there at the top. I think this one's connected to PubMed, and you can also see that there's an interesting question here about, I suppose, what you might call the holy grail with search, which is, can we create a universal representation for information needs? And by that, I don't just mean can we create the syntax, which is kind of the kind of simplistic approach. I mean, can we create something that actually makes sense visually and is usable and transparent for all these different communities of users? I do think that is quite a challenge. I mean, we're some way down that road, but I still think there's quite a lot of work to be done yet. Some of the things that are built into the solution that we have so far is the automatic translation. As I said, it connects to 12 different databases at the moment, but there are also automated translations for many more. You can see that panel there on the right, where there's translations for, I can't quite read it, I think it says Ovid, Medline, Cochrane Library, Embase, Urban Science. These are all the translations for medical databases, by the way, because we're connected to PubMed at the moment. And there's also error checking built in that bottom visual. You can see there's a messages tab. So borrowing the idea really from software integrated development environments, providing real-time support for the user if they use an operator that isn't supported by that database. Or try to create some sort of expression that isn't supported. We give them some help and guidance along the way. So yeah, and just I guess one final thing. I'm not sure. I think I've got about 5 minutes left. We recognise though that the whole world isn't suddenly going to go visual overnight. Back to what I was saying about the Boolean string and form fill user interfaces have been the way this has been done for 50 years. So I don't anticipate that changing anytime soon. So for that reason, we've also built in what you might call interoperability with legacy formats. So if you do have a search strategy that's written, with traditional Boolean strings, you can read it in and visualize it on the canvas, which actually neatly segues into the challenge that I gave a minute ago, which was that healthcare strategy of whether you can visualize it or not. And I've asked that question several times at various events, and only one person has ever got it right. So I will do the reveal. If you read it in and visualize it using, this is the nested visualization, but there are two other visualizations as well. So they all have strengths and weaknesses. But anyway, this is the nested one, which shows it as 4 different boxes. And again, borrowing the ideas from Anik, you can see the negation done as inverse video. And you can see the attribute value pairs of, most of these terms here. My mouse isn't going to work. Oh, it does. Yeah, you can see the attribute value pairs here and the nesting and the hit counts as well, and the Boolean operator there in the top right. But as I said, this is just one of 3 different types of visualization. So that's kind of where we're up to with the query formulation piece. But it's only part of the solution, because even though we've designed out a lot of the sources of error with query formulation, there's still the task of how do you actually choose your keywords in the first place? And when should you be using controlled vocabulary terms? And, a naive answer to this might be, well, that's just a query suggestions problem, and that's a solved problem because here it is in Google and it works perfectly well. But of course, that's not going to work for a structured search, because those query suggestions have to be context sensitive to the particular expression or sub-expression within the composite search that you're dealing with. So there is no existing proprietary solution for this. So we had to do a little bit of research into what kind of query suggestions would be appropriate and what kind of user experience to build to allow people to invoke these query suggestions on demand. Again, this is the sort of thing which is better conveyed with an actual demo, but I've just got the static visuals here. You can see with the image on the left, what we've done is we've right-clicked on that term, which I think is something to do with landlord, and can't quite read it, but it's something to do with it's a legal search, something to do with a Landlord and Tenancy Act or something like that. So you can see the solution, the suggestions have come up here on the left. In this box here, and you can select the terms you want. And likewise on the right, we've got a healthcare search. Same idea, we've got query suggestions available on demand. And very briefly, you'll also notice that the source of those query suggestions varies depending on whether you're doing a healthcare search over here on the right, or something to do with property law over there on the left. Now, the background to this, again, is in the interest of time, I'm not going to go into it now, but we built an API and we looked at various different techniques for generating query suggestions, looking at linked open data sources on the left with DVpedia and Mesh, which is a controlled vocabulary, and various other sources. And then we looked at what are now called large language models, although they had a slightly different name when we did this back in 2019. You can see that in the middle. And we took bespoke language models. We took language models that had already been built and built a couple of bespoke ones ourselves from various sources and placed those online and built an API around them with load balancing and all the things that you need to do for authentication and persistence and so on. And various other sources that we tried that didn't work that you can see listed there over on the right. But again, so there's an NLP or AI, well, an NLP backend to this as well, which is what we use to drive those query suggestions. But I'm glossing over the detail of that really in the interest of time. So kind of to draw these threads together then, we've done the research, I guess, into thinking about how can we turn search from slow thinking into fast and slow thinking? How can we learn from the software engineering community and borrow ideas and principles that work there and apply them to the task of search strategy generation? And how can we address, the fact that there are so many errors in these published search strategies? Is it really that the people creating them are just no good at their jobs, or is it more likely that the tooling and the paradigm is not fit for purpose anymore? So that's kind of the technology piece, but I think where we're probably going to head next is thinking more about the community and the content. So this again is a complex thing. It's one thing to build technology and put it out there and say, try this. It's entirely another one to build a community around it. So that's one thing I think that is an upcoming challenge, is what would Stack Overflow for search look like? Who would join that and who would contribute to it? And also, what about the content? You know, GitHub is such a crucial part of most software developers' practice these days. Learning from that and taking code and sharing it. What would GitHub for search actually look like? And those are two thoughts that are challenging our minds for the next wave of development. So that really is it. It's bringing these threads together. What we've tried to do over the past few years, I guess you could call it reimagining advanced search. We've looked in particular at different professions, you know, of healthcare, competitive intelligence, recruitment, and media. But I guess a significant proportion of this would be applicable to certainly those archival searches that would need to be rigorous and repeatable. And what we tried to do is design out syntactic error, make the semantics more transparent, and provide support for all the things that we take for granted in the software development community around optimization and best practice. So that also gives us the transformations that you can see there, from slow searching on the left to what you might call fast searching on the right. It's freely available to use. We've hosted it at 2dsearch.com, and there's a lot of tutorial videos as well. So if you want to give it a try, you know, we'd love to hear your feedback. So I think that's it. Those are my contact details. Always happy to, you know, take questions. We'll give a demo, but that's it for today. So.
Great, fantastic. Thank you so much, Tony. Thank you. A few questions from people who are attending online, so perhaps we can start with those questions, and as usual there will be an opportunity for everyone in the room to ask their questions as well. But let me start with Dara, who has a question about the link between human behavior and search strategies. So how will those human behaviors change, you know, when we change our search strategies? What is the link between the two?
Between, was it
human behavior and search strategies?
Well, okay, this is probably lots of different ways of answering that question. If the theme of that question is all about behavior in terms of effectiveness and accuracy, I would like to think that the behavior would change in a number of different ways, in the sense that the systems that we have at the moment, a little bit like the discussion we're having this morning about black boxes and so on, are fairly obfuscated, and the algorithms by which content is retrieved are generally not open to public scrutiny. In the world that we're sort of trying to build here, it's a much more playful interaction, in the sense that you can manipulate things on the canvas and you can undo things, and it's arguably more transparent. So, and the retrieval algorithms themselves tend to be set-based rather than ranking-based. So that we're trying to design out a lot of these sources of lack of transparency and bias as well. So I'm not quite sure if that's the theme of what the question was driving at, but that's certainly one way in which the search activity itself would change.
Okay, interesting. There is another question from Lorenzo about linked open data. I mean, could you perhaps say a few words about linked open data, and how could it be a solution to improve the way we search for information?
Yeah, so I showed briefly the query suggestions, and those are obviously generated dynamically from looking at the terms that you have in your existing search strategy. And there's lots of different ways of generating. Basically, query suggestions are related terms in some way. So the question is then, where do you get those relations from? And again, a little bit like the discussion we had this morning, you can have symbolic curated relations that are maintained by some editor, which is typically what happens with linked open data, although not exclusively so. Or you could have distributional connections, which are generally created by some sort of language modeling approach, which would be machine learning. So there's room for both. And in the work that we did in evaluating linked open data with the large language models, I've got spoiler alert, the large language models did come out better, but actually the best solution of all was combining two. Because linked open data are good at certain types of search query suggestions, and large language models are good at certain others. So you can actually get sort of the best of both worlds by combining two.
Okay, fantastic. Thank you so much, Tony.
Yeah.
Do we have questions from people in the room? Anything you want to ask at this point, sir? Not immediately. Well, I have a question for you, Tony, about searching, when you have a huge data set. And of course, this particular workshop is on artificial intelligence. So how do you see the future of AI, to search for this huge mass of information, huge data sets?
Oh, that's a big question. I think this is where it's like, is ChatGPT going to replace Google? I don't see that happening soon. I think, there's part of it is the transformation of search being, through different channels and different media. A lot of search these days is done through, handheld media and touch screens and voice. So it's changing in that respect, and I think AI has clearly played a big part of that in mediating the speech recognition, certainly the intent recognition, and this is something that Google has obviously heavily optimized, and so have a lot of other people. Facebook and Amazon have got significant investments in this space. So I don't see sort of AI. I can see AI continuing to play a big part in that. Does that answer your question?
Yeah, absolutely. Thank you so much. So we have another question from Megan, who's one of our online attendees, and she wants to ask about the audience for your tool. For example, did you have consultations with medical health professionals, perhaps people working in the library sector, as part of those health sectors?
So originally it was inspired because we just actually felt the web search was a little bit broken. So the original idea was replacing advanced search on the web. So it was more of a tool for everybody. But we rapidly realized after a while that the real value was people for whom the search needs to be repeatable and comprehensive. And there's a due diligence aspect associated with it. So at that point, we started to pivot and focus a little bit more around the healthcare profession. And a little bit around recruitment as well. And we positioned it then as a specialist tool for those specialist professional searchers. But ironically, the biggest growth over the past year in terms of users of it has been in researchers and students in the academics. Because let's face it, most students hate doing literature reviews, and anything that we can do to ease the pain and help them get over that barrier of how do I create a repeatable, defensible search for my thesis can offer a lot of value. So actually, we've kind of come full circle, and we're now sort of thinking about how can we democratize this and make it available to a much wider audience, not just professional searchers.
Okay, great. Thank you so much. So we have another question from Marcos, again online. He's asking quite a technical question about ISO. So would there be use in having ISO involved in creating a standard visual query language? So the question is very much about ISO as a standard visual query language.
So by ISO, does the question mean International Standards Organization? Is that what it says?
It says similar to SQL.
So I can't quite see it be on that screen. I can't quite read it with these glasses. Oh, SQL.
Similar to SQL.
Similar to SQL.
Oh, I see. Yeah, absolutely. I mean, this is one of the things where I think this shouldn't be driven by proprietary or at least, individuals. This is a community thing. And that's why we stopped short. Obviously, we built the tech because we're techie people, but we're not, we're not librarians, we're not end users. So that's why we stopped short of creating the content and creating the community, because that's something we would very much do in partnership. And it's the same thing. I can't quite say. So I think I've got the question, although I can't quite read it. Absolutely. I think this is the sort of thing where it would definitely benefit from a much wider consultation. Whether the ISO would be interested in it, I don't know, but I certainly think that would be a very useful endeavor. And I'd certainly be very much in favor of that.
Okay, great. Thank you so much, Tony. Do we have another question from people in the room? No, not at this point. Okay. Oh, okay. Sorry, Jenny, I didn't see you. Sorry, go ahead.
I'm just wondering, you integrated it with 12 databases.
Yeah.
So I'm just interested in what those databases are in terms of, are they all the same kind of database? Are they all like relational databases? Or
Oh, no, I meant literature databases. So actually, that's a little bit of a catch-all term because the first three on the list are web search engines. So it's Google, Bing, and Yandex, which is the most popular search engine in Russia. That was a good idea at the time. Anyway, we're reconsidering that now. And then there's all the other ones which are sort of publicly available. So it's PubMed, there's a whole bunch around healthcare, and we're just about to do a new release with Google patents and Lens patents. So the IP community can give it a try, which is a community that we haven't really had anything to do. But occasionally I get emails saying, could we use your tool for intellectual property? And I also, well, we'll come back to that one day, and we're just about to. So it's 12 at the moment, mostly, publicly available web databases of some sort, plus a few more just about to be released. So it'll be 14 as of February. I mean, in principle, when you go to, you're in academia, aren't you? When you go to your library and you see that list of databases, you'll see an A to Z list of databases. It's usually about 100 plus. In principle, there's no reason why we couldn't integrate with any of them or all of them. It's just that each integration takes a couple of days to figure out their syntax, to figure out how to write the code to do that mapping. So it's just a question of time and priorities, but there's no reason in principle why we couldn't federate and search all of them. No technical reason, at least.
it's about query building, isn't it? So you're building a query, and the integration is around converting the query that's been generated visually into the query syntax.
Exactly. Yeah. And doing it in a way that is invisible to the user, because most users don't want to get bogged down with syntax. But if there's an issue, surfacing that in a way where they can do something to fix it.